Okay, so yes, here we go. So yeah, welcome everyone. We are super excited to be partnering today with LexisNexis. And I'm going to start with an introduction to WWCode and our mission, and a little bit about the WWCode data science community. And then I will introduce our speakers, Soha, Subhasree, and Yijia. And I will ask them each a question about their experience in tech, and then we will pass it on over to Soha. So yeah, my name is Sapphire Duffy, and I'm a leadership fellow at WWCode with Naomi Freeman. And I'm an AI engineer at Kino Software, which is a company based in the UK. And I joined the WWCode global team a few months ago. And yeah, I'm just super excited to be here today. And this is our awesome team behind the data science track. So the team doing amazing work, work really hard in leading our community. So massive appreciation to them. And I know we have Helena here today, who is who's attending the talk. So welcome. And our WWCode mission. So for all of you that aren't familiar with the mission, WWCode is a global nonprofit that's dedicated to inspiring women to excel in technology careers. And our vision, so we envision a world where women are proportionally represented as technical executives, founders, PCs, board members, and software engineers. So across the world, we have over 230,000 members, and we have 70 networks in 20 countries. We have members in over 97 countries. And so far we have had over 10,000 events, and we give away daily conference tickets worth $1,025 worth and $2 million worth of scholarships. And on our website, we have access to jobs and resources as well. And so our movement today, so we all know that like the world is in a very strange place at the minute. But as the world changes, we can be a connecting force that creates a sense of belonging while the world's being asked to isolate. So a little bit about our WWCode conduct. So please take a look at our code of conduct if you're not familiar, but we follow a strict code of conduct that's embedded into our community. We encourage our members to have an inclusive mindset. So if you feel that something's not right, you can fill out an incident form and we will look into it. Or you can always email us directly to datascience@wwcode.com. But we want this to be a safe community where everyone feels safe. So yeah, a little bit about the track communities. So we got a lot of requests about a year and a half ago about women that want to deep dive into technologies. So last year the tracks were created. And this is a data science track. So we run a lot of tech talks, workshops, tutorials, training, live streams, study groups, and a lot more. But if you're not a member of any of our, a member of our Slack group or on a member of our track, I'll put in links after this talk so you can join. And if you want to get involved and become a volunteer, we are looking for volunteers at the minute. So please, if you're interested, go to wwcode.com and you can fill out a registration form or reach out to myself at sapphire@wwcode.com. And today, we would like to introduce, we're going to be talking about exploring open legal question answering system with LexisNexis. And the speakers that we have today is Soha. So Soha is a data scientist and tech lead working in innovation labs at LexisNexis. And we also have Subhasree, who is a senior data analyst, and she works at the Raleigh and NC. And we also have Yijia, who is a data analyst in the product and analytics team. And she has worked in the company for a year. So now I'm going to pass it on to you to give yourself an introduction because we'll know a lot more about you all.
Hi everyone, I'll start. I'm Shubhashi Chatterjee. I'm a senior data analyst with LexisNexis for almost 3 years now. My tech journey started when I decided to pursue undergraduation in computer science and engineering back in India from West Bengal University of Technology. After that, I did work with Infosys as a software engineer for almost 4 years. Though I was a software engineer, my work revolved around data a lot. So I use data to develop insights, create reports, and I realized that I like data a lot and I want to pursue that as my higher education and also a career in data analyst. So I decided to come to US and I did my master's in business analytics from University of Cincinnati. And then I worked for a company called WWCode for a while, and then I joined LexisNexis. So in my current role, I work with product and UX, and I try to infuse data in every stage of product development cycle. So beginning from discovery to delivery and also in maintenance, I try to infuse data and make sure that we are defining all the decisions based on data. Other than work, I'm also very passionate about women empowerment. So I work with the local chapters of Women in Tech, Women in STEAM, and many such organizations and Women Who Code as well. Other than work, I am an avid runner. I am a long distance runner and I'm also a coach with Girls on the Run.
I guess I will continue. I'm Yijia, and also a data analyst on the same team as Subhasree on the product analytics team. And I started to pursue data-related major, the statistics from my undergraduate in US. And I did multiple internship at that time and found out solving the problem with data support is very fascinating to me. And at that time, I want to pursue the statistics with a graduate degree at NC at that time. And after graduate, I just started my career path in LexisNexis, so about for 1 year now. And I still learn, I am still grows and learns a lot of new things. And I works with multiple product groups to track the usage and develop key metrics to measure the product success. So like I create Looker dashboard and communicate with multiple product teams.
Hi, I'm Soha Khazaeli, and I'm data scientist and tech lead in the innovation labs at LexisNexis. My career path was not very straightforward. After my bachelor, I worked as a software developer, and then I've got my master, then started working in academia, and I was teaching and I was faculty member for around 8 years, but then I started to my education to get PhD, and I came here to US. Then during the education, I decided to change the path and join the industry. So during my PhD, I also was working as software developer, and after completing it, I applied for the jobs according to my area of expertise, which was natural language processing, and I joined LexisNexis 4 years ago. And from when I joined LexisNexis, I worked on different products, again, still on natural language processing domain, and different product like Commander system, and now specifically on question answering system.
Thank you. You all have very fascinating backgrounds. And, I'd love to know more about you all, so I'm going to ask you a few questions. So we'll start with Yijia. So what skills or qualities do you need to do your job, and what does a typical day or week look like at LexisNexis?
So I would say for the qualities and skills, I guess I have a statistics major background, and I think my experience is pretty still young, but I think that would be useful for those who just learn some knowledge from online related courses or schools that want to start a new career in the data fields. So for me, I feel like as a data analyst, we need to know the basic data analysis progress. Like in our group, it doesn't matter if we need to know R or Python as long as you can write one language you are comfortable with. And but I think SQL is pretty necessary because we all need to write queries to pull large data sets from the database. The process is like cleaning the data, know how to deal with different data types, and how to manipulate data to answer stakeholders' question, and how to visualize data to deliver understandable report. Besides these hard skills, I feel like some soft skills are more important after I start the job. Like for example, like the speed is very important. How we getting and putting the data that is kind of relevant and promising, how to get the data ready, and how to get the data summarized. And most importantly is how to deliver data summaries into stakeholders' brains, because I work with multiple product managers, and not all of them know the relevant data knowledge, but we need to deliver it in an understandable way and more efficient way. So a typical day is like, I think 20% of the time I am integrated into different feature team and have regular meeting with PM and also the UX person, since the product I work with is also a new product just launched last year. So there are many new features and functions could be changed. We discuss the progress of release and also the UX new designs and what usage needs to be tracked. And 40% of the time, I'm designing the success metric to measure the success of the product. And also 10% of the time, I would doing some small ad hoc requests from other products. And other time, we cooperate with engineering team and do some A/B testing. Also like the team Libra, which is an engineering team that help we cooperate together to improve the data quality and make the company more data driven.
Great, thank you for sharing that. It was really useful to find out what your typical day and week is like as well. So and also the skills and qualities too. So thanks for sharing. So Soha, I'll pass a question on to you then. So what has helped you get to where you are, and what advice would you have for others who want to set off in a similar direction?
So the first thing that I can suggest is keep learning, in computer science and data science every day, new tools, new technologies, new concepts. So we all should just constantly keep learning and allow ourselves to make mistakes and learn from it, and don't hesitate to take some tasks that we are not familiar with that at the 0 point, but we will get to it. This is the first thing. And second, I talk about myself, job satisfaction is a important part of my life and being happy. And I would divide it to two parts. One, the work that I'm doing and the job that I am doing, if I love it, if I like doing it constantly, and also the people, my colleagues, the relationship that I have with them. And I try to make my part to be successful in do these two directions. So I'll try to grow in direction of my interest. So I know what I like. I know what topics and what area I'm more interested. So I try to grow in that area so I could be more influential and impactful on those areas. Also, I'll try to be a good team player. So when I am a good team player, so the other teams also like it's a two-sided relationship, and it's one of the most important part of a job that you have a team, that it's a everybody respect each other and learn with each other, and every one of us should play a role to make it such a team.
Yeah, thank you, Soha. Yeah, you're totally right about that. So job satisfaction is, you know, like, important as well, and it's important to be happy, and yeah, being a good team player too. So thank you for that. So I'll pass a question on to you, Subhasree. So what has been your biggest challenge, and how did you overcome it?
Yeah, so my biggest challenge, and it's not something I have completely overcome, probably I face it every now and then, even in day-to-day life now. And I would say that's understanding your what. So, and I want to talk about that here in this group specifically, because I feel that lots of women feel this way. We often feel that we are probably not good enough, or we are not yet ready to take on a new challenge, be it getting a new job or asking for promotion, or like even to pursue higher education, right? But I have realized that every time I have taken that step, be it changing my career from a software engineer to a data analyst, or deciding to pursue my higher education in a completely different country with a different culture, I have been successful. But there always has been those times when I wasn't really sure if I had it in me. And it took a lot of courage and day-to-day practice to kind of overcome that. And it also helps, I guess, to have a team who are very supportive of you, who are always encouraging you, and who are like there to lift you up and to believe in yourself. So I have been very fortunate to have those kind of managers, colleagues, and friends in my life. And the last thing I believe is and that I've learned actually from my running journey, that persistence and resilience. I believe that these two are the main things, that if you keep at it, if you don't give up, and if you have faith in yourself, then ultimately you will reach whatever you are driven for.
Thank you for sharing. That was really inspiring as well. And I think it's so important, like, to understand your what and to believe in yourself, and just, you know, having a good team around you is important as well. So if you're surrounded with people that's maybe not lifting you up, then maybe try to find people that will as well. But yeah, no, that's very inspiring. Thank you. So yeah, so I guess I'll pass it on to you now to start your talk. And if anyone has any questions, please put them in the chat as well, or the Q&A bit at the bottom too. But yeah, super excited for you to start your talk now.
Okay. Okay, today I will talk about a legal open question answering system, which is a feature that is recently released in the newest LexisNexis search platform. The feature is built by Embedding team, including data scientists, data engineers, software developers, product owners, and subject matter experts. To solve a problem, we first should know the problem. So what is the question answering system? Let's ask from Google. So as you see, question answering is a computer science discipline within the field of information retrieval and natural language processing, which is concerned with building systems that automatically answers questions posed by human in a natural language. As you note, I, as a human, ask a question in a natural language, and Google answered the question using question answering system. But why open question answering system? There are different categories of question answering system from different aspects. I want to show you two main categories of question answering system with an example. When you ask something like, who is Harry Potter? In the Google page, you see a top answer, an answer in top, and also an answer and related info at the right, and at the bottom you have the document search result. The answer is top. You see a passage that comes from a document and answer the question. This is provided by information retrieval based question answering system, which is one main category of this question answering system. On the right, the answer is provided by knowledge-based question answering system. In knowledge-based question answering system, you should have pre-mined data set stored in knowledge base or a knowledge graph, and you are limited to that data set that you have. So you can answer a specific kind of questions that you have data for it. On the contrary, information retrieval systems don't need mining the data, and as long as your content is rich in the domain and your solution is accurate enough, you can answer almost any content question. Because of this reason, this category can be called open question answering as well. And at the bottom, you see the document search result. Now let's talk about the domain. LexisNexis is a tech company serving law and legal companies and entities. It is important for a data scientist to acquire some domain knowledge. It helps to understand the problem fully and then propose or develop more insightful solutions. For example, imagine this scenario. Lawyers do several tasks each day of their work. One of their main tasks as litigant lawyers is legal research. Imagine John Doe was fired from his job because of his sexual orientation. He wants to sue his former employer. Keller, the attorney, thinks they can make a claim under a hostile work environment. She will first need to research several issues, such as what are the elements of hostile work environment? What are the protected class under Title VII? Do Title VII cover sexual orientation? LexisNexis products are the main source for Claire to do such research. So she would go to LexisNexis product and search. She can find many contents, including the cases that are relevant to the question. She can use and cite these cases in the document she is writing, such as motion or brief. Without providing answer in the top of the document search result could help Keller to have more efficient search experience. Based on our domain knowledge, we know that factoid answers are not that useful for lawyers. They need more extensive answer to use them. Also, in many cases, there is not just one right answer. Lawyers need some alternatives to see which one applies to their case best. So based on this info, we decided to develop an information retrieval based question answering system. Now we should talk about solution. First step is literature review to find how other successful systems solve similar problems. If you're familiar with QA, that I saw a poll now that there are different audience here from novice to expert in this area, in the audience. So some of you might have seen this architecture, this overview, that it's a two-step question answering system overview. As you see, retrieval system finds the most similar passages or documents lexically or lexically or semantically to the question and provide top X passages. These passages are similar to a question, not necessarily answer the question. And the second component, which is called reader, ranker, or comprehension system based on the application, between those top X passages, find the answer or rank them and find the top K answer. Again, based on our domain knowledge, we decided that ranker is the best solution for us. Inspired by successful research projects, we developed our product architecture, including offline and online components, to load and digest content and provide good answers to legal researchers' questions in our newest search platform called Lexis Plus. I'll go in details for different components in a simpler diagram. The first important question is, what is our content? LexisNexis serves many types of content, but the most sought for content type is case law. So we chose case law as our main content as well for now. But case laws are long and we needed smaller and digestible passages as answer. To have a cost-effective solution, we decided to focus on just important passages, not all paragraphs of the case laws. These important passages are head notes and reason for citing. Head notes are passages from case law that handpicked by LexisNexis editors because they are describing a point of law, and reason for citing are passages that are assumed to be important since they contain case citation. In our pipeline now, we have more than 100 million passages, including head notes and passage and reason for citing. Also, every day more case laws are published and added to LexisNexis data store around from all around the country. And therefore, we have pipelines that not only can extract the passages and embed and digest them into our retrieval system, but also it does the same steps daily to cover the new case laws. For our customer, it is vital to access to answers in the recent cases. The component that plays role in the online process are shown in this simplified diagram. So here I briefly describe all the things that our system will do in summary, and we can then go in more detail in some part of it. So when we get the user query, we have a component called Orchestrator that coordinates between our sub-components in the system. First, it sends the user query to question recognizer. Question recognizer finds that if this is a question or it's a regular query. If it is a question, we will engage and answer. Otherwise, we don't. Question recognizer also do some other jobs like jurisdiction recognizer and reformulation in some extent. After Orchestrator found that this is a question, it sent question to vectorizer to vectorize the input question with a desired embedding method and return, get the embedding. Then Orchestrator send the question along with the embedding to retrieval component, and retrieval component query our Elasticsearch both by text, query text, and also query vector, and retrieve alternative passages that are similar to the query. Now, because we want to know which one of these questions actually answer the question, we send them to answer finder. Answer finder find the probability of each of these passages, that how good they answer the questions, and return this probability to Orchestrator. Orchestrator then, using this probability, can pick and choose which one of these passages are good answers and can send them to the user. So each of these components have their own stories and worth talking about, but here I just briefly talk about retrieval and focus more on answer finder. Conventional retrieval system use lexical index, like BM25 or more like this. These are BM25 and more like this are built-in feature in the conventional search platform that bring the relevant documents, and both of them are based on TF-IDF. So shoot for find answers that are more related to the important term in the question. Lexical retrieval system are very successful on retrieval, but they have some shortcoming. The most important one is sensitivity to exact words. If, for example, user use a term salary in their search, they don't get documents with wage in the result. There are some solutions for that, such as having and maintaining alternative phrases in the search platform, but more general solution could be using semantic index. How? By embedding. Sorry. In the recent years, different embedding methods emerge and cause significant progress in NLP. Before embedding, to vectorize a word or document, we could only use the existence or number of occurrence of each word between all the words in the dictionary in a certain document. These sparse vectors could just capture lexical form of the word. Embedding methods provides a dense vector for the word or document that capture lexical, syntactical, and semantic characteristic of word or the document in some extent. How these embedding methods are being created is out of the scope of this talk. Here I can say the old, like not old, but like older than the others, embedding methods like word2vec and glove could produce vector for each word, but the problem was they had same vector for ambiguous word. For example, bank as a financial institute has the same vector as bank as a side of the river. Elmo came to solve that problem and have contextualized word vectors. So these two banks would have different vectors. Then Google BERT came and was like explosion in NLP and helped all NLP tasks. With Google BERT, you can have embedding for word or a phrase or a sentence or a passage. So you can have embedding for more span of the text, longer span of the text. And also Google BERT is a general embedding method. Then you can fine tune this general embedding method for your specific task. Here in the retrieval system, our task is similarity. We want to find the similar documents to the query. So sentence BERT or Siamese BERT is fine-tuned BERT for task of similarity. It is fine-tuned the way that two input sentence have the most similar vector, BERT vector at the end when it's fine-tuned. All of these models are trained based on the general data set, like Wikipedia, news, or stories. But when your domain is different, it's better to use to train these models in your domain. So in our team, my teammates trained legal glove and legal BERT and legal Siamese BERT, and we use legal Siamese BERT for retrieval system. Now let's focus on answer finder. Given a question and a passage, answer finder predicts the probability of the passage answering the question, how good answers the question. The idea was we will have different alternative similar passages, some from lexical retrieval systems, some from embedding-based retrieval models. We also have some existing answer cards from our previous knowledge-based question answering system that we wanted to take advantage of them. It would be good if we had a component to get each question and passage pair and find out with what probability each passage answers the question. Then we could show the passage that answer the question best to the user, or use that ranker concept. So answer finder is a BERT classifier. Our legal BERT model is fine-tuned to classify a question and answer pair as either valid or invalid. BERT for sequence classification is a BERT method that gets the representation of the first token and use a dense layer for classification. Here you see a schematic view of BERT classifier that encapsulate all the 12 years of transformers and multi-headed attention layers. At the start, we feed our query and passages to the BERT classifier, tokens of our question, separator, and tokens of our passages. At the end, a dense layer classifies the representation of the fine-tuned embedding of first token of the sequence to valid or invalid question answer pair. But training data. Creating decent amount of training data is expensive, so it is recommended to use open data set if suitable. We use natural questions, which is released by Google, and this is open data set. It contains 300,000 questions in the training data set. We were focusing on long passage answers, so we filtered based on that, and we ended up with having around 100,000 questions. But these were just general question answers. We needed more domain-specific training data as well. So for adding legal question answers, we got questions from user queries and extracted answers based on our retrieval systems and passed them to our legal subject matter experts to annotate them. Our SMEs have a specific rubric to annotate the answers, and they categorize them between -1 to 3. -1 means so on related that may cause a user to lose patience with the system. 0 means irrelevant answer. 1 means relevant topic, but not necessarily answer the question. 2 means partial answer, and 3 means good answer. But we are creating a binary classifier, and our natural question data set also has just annotation of positive and negative answers. So we should map these 5 scores to 0 and 1. So -1, 0, and 1, we treat them as negative answers, and we treat 3 as positive answer. And we only use 2 answers if there is no good answer. How we fine-tune BERT, these are the hyperparameters that we use. The maximum sequence length, we started with 512. It means the number of tokens that can be fed to the BERT classifier. But then with some experimentation, we saw even if we make it lower to 128, we don't lose significant accuracy. On the other side, we will have much performant components in the production. The training batch size could be 32, the usual learning rate, and the number of epochs we set at 3. On the validation set, we got F1 measure of 64% and accuracy of 81%. Based on the inter-rater agreement experiment between our SMEs, our estimated human accuracy was 89%. So 81% for our model was acceptable, but we always try to make it better. This is data science chapter, so I probably you know these metrics, but because I mentioned about F1 and accuracy, I go over this slide briefly. So in our application, precision is the percentage of actually correct answer within all passage that the classifier predicted as correct answer. Recall is the percentage of answers that the classifier correctly predicted within all actual answers. And as you know, precision and recall usually go in the different direction. F1 measure is a metric that combines these two. Accuracy is the percentage of passages that the classifier correctly predicts, no matter it's negative or positive. So we wanted to have a fast development loop with our evaluations. So we decided to have to design an experiment that enable us to do this fast development loop. So we sampled our content, 10% of our content, and also our question set is 10% of original test question set. And we limited our pipeline to a simplified retrieval system and answer finder ranking. So we didn't use all of the other refinement that it is in our production system at the end. In the result, we designed a faster evaluation and development loop, but it gives us lower metrics than the production metrics. But it's not important because we just want to compare between our methods and models. We know that these are lower than the one that we will have in the production. But if in the comparison we can find that this method that we are trying is better than the other method, it's the point for us. And in this evaluation, we talk about DCG, and we look at DCG a lot. DCG is an important measure in the search and can be used in the question answering system too. And our company is very looking at DCGs very carefully usually. So DCG is measure of ranking quality. It is often used to measure the effectiveness of a web search engine algorithm. And to have a good DCG, you should have high quality answer or search result. And also these good answers or good documents should be in the top of your list. So both quality of the answers and the rank of the answer is important. So for example, if you want to compute DCG at 3 and you have this scale, 3 good answer, 2 partial answer, 1 relevant passage, 0 irrelevant passage, and in the 3 your first answer is a good answer, the second is relevant, and the third is a good answer, you would have these scores. The first one because it is in the first in the rank list and also has the higher score to the power of 3 minus 1, 7, you get the this score. But the same good answer, if comes in the third location, because of the denominator, you would get the lower score. At the end, you add this score and have DCG for one question, and then you can average this DCG over all of your question and get the average DCG. So in our development evaluation, we compared methods like lexical retrieval system, more like this, and Siamese legal birth and glove. And also when you have, for example, 30 answers from more like this, and apply answer finder on top, and the rest. This is our table to compare between these methods. We found using answer finder at top significantly improved the DCG, as you see. We also saw if we combine our lexical retrieval system like MLT and a semantic one like BERT, and then feed to answer finder, we will get the best DCG at the end. We also decided that we pass around 30 passages for each method to answer finder. So this helped us to get our decision and set up our production. But at the end, when we want to track our real accuracy and improvement and find out if we reached to our predefined success goal, we have a test set of questions that around 1,200 questions from user queries and also SMEs. And SMEs went through and reviewed all of the answers that came out of our question answering pipeline. And at the we have the average DCG at 3 of 7.33 and average DCG at 9.69 at the last evaluation that we did. It was like always improving and also past our success goal. And I can demo that in the production. So this is Lexis Plus, and if you have the question, what are the protected class under Title 7? You get these answers. You can see more than 3 answers if you want, and you can click on any of that and go to the case law to see more data, more context around that answer. You can ask any question, like is airline liable for air crash, or what is the difference between first-degree murder and second-degree murder? So you don't have any limit on the questions that you can answer. Thank you all for listening, and also I should thank Marka and Rashni who helped me in creating a slide deck. Now it is time for question and answering.
So thank you so much, Soha. That was a great insight to the Open QA system, and it was really interesting talk. I learned a lot from that there, and I'm sure a lot of our participants have as well. So thank you. I've noticed here in the Q&A you have 2 questions. So we have one here from Lalima, and she asks you, how do you decide the architecture or work process for the QA system?
So as I showed, we did literature review and saw some successful overview of the system. It was inspiring, but it is like different from the reality and the system that we try in production. Each of these components have a lot of questions if it is performant enough to do it in the production or not. So it was a lot of every one of us had idea and have some suggestion, but so this evaluation loop that I explained helped us to find the most the most impactful component and the setting that we want to answer the questions. So we designed based on our suggestion and communicating with all team member, and also based on the data that we got based on our evaluation.
Okay, thank you. And we have another one here from Jeff. Said, Soha, this seems very technical. Did you experience in the Q&A area before you worked in this project? If not, how did you learn this approach to solve the problem?
So I joined LexisNexis 4 years ago. The first thing that almost the first project that I was assigned was a question answering, but not with this approach. We followed the question answering, the knowledge-based approach. So I had this experience, and like also followed the like others work, the research around this area, and like after a while and being in the domain and following, you get also some insight. So like as a team, we communicated our insight and proposed our parts, and this system has different parts that every one of those have an impact to the decision that we gain. And at the end, it was a successful experience.
Thank you. We have another one here from Mita. Interesting insights into the retrieval system. Anything on how to address the ambiguity of words with multiple meanings in a question, given the limited context?
Could you like read it again? Sorry, I didn't get some parts of it.
No problem. Interesting insights into the retrieval system. Anything on how to address the ambiguity of words with multiple meanings in a question, given the limited context?
Oh, so the query, like usually short, and maybe they mean that like there's no a lot of context around it, and it could be ambiguous. Is that true if the question is not like, well, like it's question, yes, could be ambiguous. We have like actually a lot of queries that when we review, like there could be several meaning out of it. And yes, when question is ambiguous, then answers also, like it could be on like point or not. And but with this like embedding system like BERT, we can take all of the context that we have on the query, but the query is short and it might not have enough context. And on that case, we don't have any solution. So we provide some answer. It could be on point or not.
Okay, thank you. That's all the questions then we have. Oh, sorry, we have another one, sorry, from Lalima. As a follow-up, how do you perform retraining and redeployment to keep the models always updated to the newest data that you get? In my experience, it has always been a cumbersome task.
Yeah, you're right. Like all of the models could became stale. So this is our this question answering system is like almost new now, but we have like user stories in our backlog to retrain, for example, answer finder to make it better, or we constantly look at the different BERT embedding models to like maybe compress those or use the newest one. And we always keep an eye on these different part of the system that could be stale. But one of the like good things about the retrieval system is your content would not be stale because you don't need mining the contents come from the case laws digestion, and it's always dynamic and it's like up to date actually. But these models could be, and we will keep an eye on these and retrain those.
Awesome, thank you. And that's all the questions we have today. So yeah, I just want to take the opportunity to thank you all so much. Soha, thank you for giving us a great insight to the open QA system. It was really, really interesting, and we can see here from the chat that everyone really enjoyed it, and everyone's saying thank you so much. It was also great hearing about all your career journeys. So thank you to Yijia, Soha, and Subhasree as well, and of course LexisNexis. From like Rushna, Joanne, and also Miki. So yeah, a big thank you. It was great partnering with you in this event. So I really enjoyed it as well, and so did all of our participants. So I'm going to start sharing my screen and do the closing slides here for our webinar. So let's see. Yeah. You can probably hear my cat too, he's very hungry. Can everyone see my screen okay? Yeah, cool, okay, so yeah, thank you very much LexisNexis. It was I really learned a lot from this event, so thank you, and yeah, it was great partnering with you. So what's happening next? So we have a networking event coming up on September the 1st, which is next Tuesday. And we are running two different Bytes and Brew events. So we're going to have one in the morning and 3 a.m. EST. We're going to try and make sure it works for most time zones across the world. So one at 3 a.m. EST and also one at 12 p.m. EST. And this event is basically for all of us to connect with each other, get to know each other, make conversations, and ask for career advice or anything like that. It's just going to be a nice networking event. Sorry about that. And yes, so we also have our Intro to Advanced Machine Learning workshop series that's coming up, and it's starting on the 5th of September, and it's going to be running for 6 weeks. And you can find all of our events on womanycode.com/datascience/events to register. And if you'd like to follow us on our social media pages, we have our Twitter, Facebook, and Instagram here. And we also have LinkedIn as well, which we recently set up. But if you'd like to take a screenshot here, if you want to follow any of our pages, I'll give you a few seconds to do that. And also, if you want to email us, reach out to datascience@womanycode.com. And to join our community, go to womanycode.com/datascience. And yeah, thank you everyone. I hope you all have a great day. And thank you for all of our participants for joining us.
Thank you.
Okay. Bye everyone.
Bye.